Welcome everyone. We are discussing differentiation. Today I will discuss derivative of implicit function. Derivative of some typical problems of implicit function. Look, root over 1 minus x square, root over 1 minus y square, a into x minus 1 minus x to the power 4, a 1 minus y to the power 4, a into x square minus y square. So, a, b, c, d. D, 1 minus x to the power 2n, 1 minus y to the power 2n, a into x to the power n minus y to the power n. Prove that dy dx equals to x to the power n minus 1 into root over 1 minus y to the power n, y to the power n minus 1 into 1 minus root over x to the power 2n. So they are of same type. Problem number D is most general. Putting n equals to 1, you get 1. N equals to 2, you get 2. N equals to 3, you get 3. So D is most general. Now if you look at the proof, in dy by dx, there is no a. So if you take direct derivative, then it is very difficult to eliminate. So we use trigonometric transformation to solve this type of problem. And I have already stated that if it is 1 minus x square, we put x equals to sine theta. So x square equals to sine theta. Here x cube equals to sine theta. Here x to the power n equals to sine theta. So consider problem number D. Let x to the power n equals to sine theta. Our main aim is to remove root over sine. So what is theta? Sine inverse x to the power n. Y to the power n equals to sine phi. So what is phi? Sine inverse y to the power n. So our original variable is x and y. So express theta in terms of x and y. Now put the value in D. So putting value, what we are getting into 1 minus x to the power n whole square. So sine square theta. 1 minus sine square phi. A into sine theta minus sine phi. This is sine theta, this is sine phi. So cos theta plus cos phi. A into sine theta minus sine phi. So put formula cos c plus cos b. 2 cos theta plus phi by 2 into cos theta minus phi by 2. So A into sin c minus sin b. 2 sin theta minus phi by 2 into cos theta plus phi by 2. So what advantage you are getting? You look, 2 cos theta plus phi by 2 is cancelled out. So we are cos and this is sine. So dividing by sine, cot theta minus phi by 2 equals to a. So what is theta minus phi by 2 equals to cot inverse a. So finally we are getting theta minus phi equals to 2 cot inverse a. So what is theta? Sine inverse x to the power n. This is theta minus sine inverse y to the power n equals to 2 cot inverse. So this is free from root over. So I have already stated while discussing derivative of inverse circular function that if you put trigonometric transformation, then you have to take derivative in the last step. So now you find differentiation. So differentiating both sides with respect to x by function of function. Sin inverse, so 1 minus x square, so x to the power 2n into d dx of x to the power n into x to the power n minus 1. Sin inverse y to the power n, so same formula, y to the power 2n, n into y to the power n minus 1 into dy dx, because we are performing derivative with respect to x, so dy dx. So n cancel. So what we are getting, y to the power n minus 1 into 1 minus y to the power 2n into dy dx equals to x to the power n minus 1 y to the power 1 minus x to the power. So finally we are getting dy by dx. So dy by dx, x to the power n minus 1 multiplied by this one, y to the power 2n, and this is y to the power n minus 1 at the denominator, 1 minus x to the power 2n. So derivative is very simple. You remove root over sign by using suitable trigonometric transformation. So putting x to the power n equals to sin theta and y to the power n equals to sin phi, you are getting a relation which is free from root over. So right hand side in terms of a, so derivative of cot inverse a is 0. So this one, this one, this one, this one, exactly same. Now problem number 2. This is also very simple. You 1 minus y square and 1 minus x square. So same transformation. X equals to sin theta. So theta equals to sin inverse x and y equals to sin phi. So theta equals phi equals to sin inverse y. So putting value here, we are getting sin theta and root over 1 minus sin square phi, sin phi root over 1 minus sin square theta equals to 1. So sin theta cos phi, sin phi cos theta equals to 1. So this is well known formula, sin theta plus phi equals to 1. This implies theta plus phi sin inverse 1. So sin inverse x plus sin inverse y equals to sin inverse 1. So this is simplified form. So differentiating both sides with respect to x. 1 by root under 1 minus x square, 1 by root under 1 minus y square into dy dx. Sin inverse 1 is 0. So from this you can find derivative what is dy dx. So dy by dx minus root under 1 minus x square and 1 minus y square will be at the left. So we are getting 1 minus y square, 1 minus x square. So these are typical problem of completion also. So you have to remember that technique. Now we consider some typical problems. So problem number 2. So cos inverse x square minus y square by x square plus y square equals to tan inverse A. prove that dy by dx equals to y by x. So, relation is independent of A. Look at the proof. You must see the proof. So, this is our given relation. So, look at the term x square minus y square by x square plus y square. So, same but they differ in sign. So, after this, so if we transfer cos to right hand side, we get cos tan inverse A. Now, this is constant, not including x and y. We suppose that this one is k. So, what is k? Cos tan inverse A. Now, this is x square minus y square, this is x square plus y square. So, for this type of problem, you know, you have to use component and differential. So, suppose this is k 1 plus k and this is 1 minus k. Because this is x square plus y square. So, denominator plus numerator. So, x square plus y square, x square minus y square. And this is x square plus y square minus x square minus y square. Now, this equals y square by x square. 2 to cancel. 1 plus k by 1 minus k. Now, since result is independent of constant, so we can write it again y by x equals to root over 1 plus k by 1 minus plus minus. Suppose this one is k1. k1. So we are getting a relation of this type. Since final relation is independent of constant, so we differentiate it. Do not transfer x to right hand side. So by cosine, so this is x square x into dy by dx minus y into 1 equals to 0. Derivative of constant is 0. So what we are getting? So x dy dx minus y equals to 0. So dy by dx equals to y by x. So this is our final result. So this will be noted. It is independent of it. That is why we are taking derivative with respect. Derivative by quotient rule. Now look, problem number B is same type of problem, but here alpha is present. This one is alpha. So if we use the same technique, transferring tan to right hand side, so we get tan alpha. So we can write tan alpha by 1 because this is minus, this one is plus. So we get advantage if we use component and derivative. So 1 minus tan alpha by 1 plus tan alpha. Look at the proof. 1 minus tan alpha. So denominator, numerator, x square plus y square, this is 1. So denominator minus numerator, and this is x square plus y square plus x square minus y square. So we are getting y square by x square equals to 1 minus tan alpha by 1 plus tan alpha. Now look at the final result. Final result involve alpha. So look in this. So you transfer x square to right hand side. So treating this as constant, we take differentiation. So what is derivative? You look. y square equals to 1 minus tan alpha by 1 plus tan alpha into x square. What is derivative of y square? 2y dy dx. And this one is constant. And what is derivative of x square? Dx. So 2 cancel. So finally we are getting dy by dx x into 1 minus tan alpha and y into 1 plus tan alpha. So look here, alpha is present, that is why we are not eliminating alpha. So exactly same problem. Now, problem number 3. X into root over y 1 plus y into root over 1 plus x equals to 0. So look, dy dx equals to 1 by 1 plus x whole square. So dy dx is in terms of x only. There is no root over. So look, no trigonometric transformation because it is 1 plus x, it is 1 plus y. So our main aim will be to remove root over sign. So remove root over sign. So 1 plus y minus y into 1 plus x. So x square into 1 plus y equals to y square into 1 plus x. Then transfer all terms to left hand side. X square minus y square. X square y minus y square x equals to 0. Transfer all terms to left hand side. So then try to factorize x minus y, x plus y. This is plus xy 1, x minus y. So finally we are getting x minus y, x plus y plus xy equals to 0. So this can be factorized. So we are getting two options. So what is the first option? Either x minus y equals to 0, so x equals to y, or x plus y plus xy equals to 0. So y into 1 plus x equals to minus x. So y equals to minus x by 1 plus x. So we are getting two options. Now what is dy dx? Dy dx equals to 1, so not desirable. Now second one is y equals to this. So you complete it by cosine. This is a very simple problem. 1 plus x into 1 minus 1 plus minus x unchanged 1. So we are getting x cancel minus 1 by 1 plus x square. So this is typical problem, no trigonometric transformation. So square both sides, transfer all terms to left hand side and factorize. Then consider y and take derivative. So this is also most important for competitive exam. Now problem number 4. E to the power x plus e to the power y, e to the power x plus y. So find dy. So we can differentiate it directly. But if we divide by e to the power x plus y, you look, e to the power x by e to the power x plus y. So e to the power x by e to the power x plus y. E to the power y by e to the power x plus y equals to 1. E to the power minus 1. E to the power minus x equals to 1. So what is our advantage? Derivative of 1 is 0. So differentiating both sides. e to the power minus y into dy dx with negative sign. And this is e to the power minus x into minus 1 equals to 0. So what is dy dx? So e to the power minus x, it transferred to plus, so e to the power minus 1. And this one is, so what is dy dx? Dy dx equals to minus e to the power y minus x. It will be y, it will be x. So dy dx equals to plus so you can take direct derivative also, but if you divide it by e to the power x plus y, it will be x. So you complete problem number 5. So today, through this video, I have solved some typical problem of implicit function. So these are most important for any competitive exam. So thank you for today.